Hello, everybody, and welcome back to another session at the A4Q Testing Summit Edition 2025. I'm very excited to be here with Bruno Legeard. Bruno has over 20 years of experience and has been at the forefront of innovation, exploring how testing can evolve through intelligent automation and advanced modeling techniques. Bruno will be discussing AI agents in testing. The future is here, but can we trust it? Before I hand over to you, Bruno, I just want to remind our audience about the Q&A session at the end of your presentation. So please, everybody, pop your questions into the chats and then Bruno can answer them for you. We also have our Best Presentation and Best Speaker Award, and you can vote for Bruno by visiting the testingsummit.com website. So with that said, I'm not going to keep everybody waiting. Bruno, we all look forward to hearing what you have to say, and the stage is yours.
Thank you. Thank you very much for the presentation. Hello, everyone, and thank you for joining this session. So today we look at how AI agents can help us in software testing. As you know, agentic AI is very hype on accelerating, but is it practically useful for software testing activities? So over the next half hour, I will show what exactly AI agents are and how we can use them for software testing. Particularly, I will focus on our experience in building an AI agent for manual test execution, an AI test runner. You will see that. So let's go. This presentation is mainly two parts. First, I will show the progression from AI chatbot, as everybody knows, to agentic AI and where we are now in this technology. And then I will share my experience in building an AI agent for manual test case execution on how we can build trust in this kind of technology, because we need trust, as you know, to delegate our task. So if just to start about how we, all of us, started in generative AI. We start with AI chatbot, as you know, developing our own capabilities on skill in prompting and using these nice tools for many activities now. And so you see the flow with prompt, user prompt on large language model from OpenAI, Mistral, Anthropic, or other. You see the logo. But what happened the last few months is that this initial technology has been growing, and the first upgrade is retrieval augmented generation. It's a very important step because RAG, retrieval augmented generation, allows us to add specific project knowledge, context data. And it's a combination of typical prompting for testing tasks with contextualization based on how to import, the relevant context from your project data. So it helps to enhance accuracy, to lower the hallucination that we have, as you know, and also to be more accurate regarding the project data evolution. For example, to be up to date with the last version of our product, our specification requirements and user stories. So it's really an important step in the technology, and now embedded in most of the chatbot with retrieval augmented generation. Another technology that is now current in our chatbot is web search. It's complementary, or sometimes you prefer to go on your own document with RAG, or sometimes you are interested in using the web search. And then the large language model decide on the basis of your prompt to make specific search to complete the processing of your data and to increase the quality of the answer. For example, question like generate a logging test in Java using Selenium 4.33.0, which is the version for May. And of course, this version is not part of the training data of our current LLM. Maybe answered by this web search that will consolidate the information. So it's another technology, another capability that is useful when using a chatbot. And the third one that involves reasoning LLM is deep search. What is deep search? It's not only one web search, it's the capability to iterate search on the basis of thinking chain of thought from the LLM, meaning from the prompt, the LLM plan activities, including some web search on the basis of what have been discovered during the search, replan again in order to complete the complete task or what you have prompted. For example, if you want to collect all the API change log from the last 3 releases based on suggest regression test, it's really an interesting capabilities to use this kind of deep search technology. So what is important is really that we have now this kind of reasoning model, not only the previous one, LLM. So LLM with chain of thought capability to plan and to reason. Are these kind of chatbot technologies, including RAG, of course, of web searches and deep searches, useful for testing tasks? Of course, yes. And all of us, we are using it, for example, drafting, generating some Gherkin style test casing on the basis of user stories, or summarizing 1,000 lines of stack trace into a paragraph, a clear paragraph of summarization, suggesting boundary values or boundary value data set based on business rule. All of these tasks can be well done by these technologies. But when you want to implement repetitive test tasks, when you want to integrate the LLM processing into your test process, the testing process on the tool chain, and when you are looking for higher degree of automation, agentic AI is the approach instead of a simple AI chatbot. So what is agentic AI and how we can use it and implement it in our testing processes? So there is agentic AI is a kind of concept on architecture. This encompasses several architecture or family of architecture. And the first one is really LLM workflows. It means that you create typically a chain of prompts that helps to deliver a sequence of LLM processing of your data. And of course, the output of one LLM processing is the input of the next one. And this you can, of course, you are access to the LLM using the LLM API, and you can embed this process, this LLM workflow, as part of your testing toolchain. For example, you can start with optimizing the acceptance criteria of user stories, and then you can go to generating some, for example, Gherkin style test cases, and then you can go to generating some automatic test code. And you can define this task, evaluate them, refine, optimize them, but implement them in in your testing process, and is what we call LLM workflows. But there is another family of architecture in agentic AI, what we call AI agent, and where the level of autonomy is higher, and these agents are built to act, not only to transform information, as we have seen before, transforming user story, generating test cases, text to code, for example, but AI agents are built to act, to really act on the system. And from a user task, the idea is really to be able to execute something based on the reasoning capability of the LLM, based on analyzing and perceiving the environment, we see that, and based on some tooling on capabilities to really act on the environment, for example, on your digital application. So both are useful, we will see that, but it's not exactly the same purpose. If we go back to LLM workflows, actually there are various different architecture of workflow. For example, I don't want to go in detail in all this architecture. You can see it, and you can go to this excellent source of LangChain. You can see the tutorial on workflow. But if we have seen this prompt chaining, which is really the basic one, LLM workflow, but the evaluator optimizer is a nice one. Then you have a generator. For example, we may have this Gherkin style test case generator, and you have an evaluator, which is another prompt on another LLM call that make evaluation with a loop, to provide back, what have been discovered by the evaluator in order to optimize and to generate again. And at the end of the day, of course, because you don't want to loop, you want to converge, of course, but you will have more accurate output. So it's, you can parallelize, you have some orchestration. So you have various ways, but it's the same idea, is to build powerful LLM workflows to address the LLM through the API, to develop and optimize your prompt, because each call is actually one prompt, and then to integrate in your testing process. So if we compare, the application of these two kind of architecture, LLM workflow and AI agent, is really the level of delegation on the fact that you want, with AI agent, and we will go deeper in AI agent, is that the level of delegation is higher, on that you want to really to act, to execute something. So if we go on LLM workflow and provide some example, you may have this prompt chaining between optimizing user story and generating test scenarios. You may analyze a test execution report and then cluster anomalies in a thread. So there are many, really nice automation you can do with this kind of architecture LLM workflows. On the side of AI agent, you will see that you can implement the test execution of manual test cases, meaning in natural language, but you can automate the updating of test case and change your repository based on impact analysis, for example. So it's really a delegation of complex tasks on that you provide some tools and capability to your AI agent. When you develop an AI agent, which is a generative AI system, you need this, building block, what's so-called augmented LLM. The augmented LLM is actually what an agent needs. Its capability to plan is based on this reasoning LLM, to also analyze where we are and where we want to go to achieve a goal, a task actually. But also you need tools, function calls. You need to be able to select tools to be able to achieve part of the plan. And you need short-term and long-term memory. Short-term to know exactly what have been done on where you are now. On long-term memory to be able to improve your capability on based on what happens before in other run, for example. So if you consider this is really extension, the augmented LLM is really extending, basic LLM with these reasoning capabilities, chain of thought, tooling, and memory. And it's really the basic, the building block of developing such agent. So let's go of the global architecture. Here we have our building block, and from the task you have the planning activity, and you select some tools, you have the memory of what happens, and you may act here. But you have the perception. The idea is that your agent analyze what is the current situation after acting, before and after acting, for the next step. For example, you see on the screen that you have this cookie pop-up with accept of project. And for example, if there is no policy given to the agent will decide, as a human tester will do, to, for example, accept or reject the cookie to continue the plan, for example, executing manual test cases. So what is important is that an AI agent take initiative. Everything is not defined. Some situation appears, but the agent has a capability to reason and to decide what to do. But sometimes it's not possible, don't know what to do, and is why we have this kind of feedback loop on the human in the loop, meaning that the agent may ask the user to solve part of to help for a decision, for example, or to provide that I will provide a demo. I will give a demo just after. So actually, if we consider, what happens in the AI agent universe, which is fastly evolving, most of the architecture are multi-agent. I give you an example on the picture. You have the task provided by the user, and here we have two agents, the orchestrator agent that define what to do next, what kind of tool, on request the executor to do it based on what have been defined regarding the current step, and the act, for example, fulfilling or selecting in a drop-down menu or whatever. And the perception can be, in this example, the analysis of the screenshot where we are on the application to decide what to do next. Because you have the plan, you want to accomplish the task requested by the user. And sometimes the orchestra decide to open a dialogue with the user because he needs some data, for example, to continue the task. So you can see that orchestrator is specialized in the orchestration activity, and executor is really specialized in execution activity, but we may have much more complex architecture in terms of the number of agents. And the important point is that each agent focus on a specific task and is much more accurate and relevant. So in summary, AI agents are general systems that can plan and act. It's both aspects very important. Most of the agents we have now are multi-agent system on orchestration of AI agent, and we have various degrees of autonomy on human in the loop. So just to make it a little bit more concrete, we will have a look on a quick demo, a short demo, on three well-known actually GUI agents. So operator from OpenAI, Manus AI, Chinese one, and browser use, which is specialized in browser agent, GUI agent on browser. So I will show you the agent. Up. Do you see my screen? Yes, I hope so. I see that you can see my screen. So you can see that I have browser use cloud, Manus, operator, and here is where I can define my task. What do you want done? Okay, so on my task is register me on the next webinar at Smart Testing in English. And you can see that I can choose LLM. This one is GPT-4o, but I can choose Gemini or whatever. Never mind the LLM. So I will launch this task, and in parallel, I will do it the same, and we will go back to see what happens on browser use. Here is Manus with the same task. There is some, of course, some specific aspect, but you see basically the same thing. You prompt a task, and I will send it. And the last one is operator. We will run it in parallel, and you have the same task. We are on OpenAI operator, and then we can launch the task. So if we go back here, you can see that the agent browser use has open a browser, then open the website, then is now trying, so the website is open, and now is trying to see what is the next webinar, because my task is register me on the next webinar on this website. And if I go to perhaps operator, why not? So you can see that he is now finding the webinar. Yes, so it's a webinar on X-Ray on Yes. And now it sees a button for registration. We are in English, but the button is in French, I see, but never mind. And if we go to Manus, we can see the interface. Where is Manus? Is now on the Zoom page, to make the registration. And you can see a dialogue here because Manus stop. And if we go to operators, certainly we will have the same thing. Not now, but is what I want to show you. I ask for registration for a webinar, but of course the agent needs some more information. Need my first name, last name, email address, organization, job title to be able to fulfill. And I can do it. I can provide the information because I want the job to be done. Okay, so let's go Manus, continue. Let's see what happens at the level operator. And I see that he's looking for, you see that the cloud browser is still looking for the webinar registration. And so, perhaps, because it's not so easy to find the webinar, actually. but you see a different capability. So you see that he's typing Bruno Legeard, etc. All the information address was he is typing. He's doing the job really. He's not processing information. He's really acting, filing some field, etc. And I am successfully registered. So good. But you see, now he knows that my configuration is in French, but you see that operator from OpenAI go to at the same point. He need information, my first name, etc. on address name. So I will stop here. But you understand what is an agent here. An agent is planning and is acting, and then dialogue with the user when the agent needs some information. So you see that it's interesting for testing. Manus has completed the current task. Okay, Manus, you did this good. Good work. Okay, so I hope it's a little bit more precise now. What is an agent, particularly this kind of agent that we call GUI agents? What we can do, you can do with and how it works. Okay, so let's go now in our experience, which is to develop an AI agent for manual test case execution on how we can build trust in this agent. So it's very simple, actually. The goal is to be able to run functional test case specified in natural language, exactly the test case that you can find in any test management tool. We focus on testing through the GUI, functional testing on the GUI. We actually currently focus on web application, but the idea is to address desktop and also mobile, but it's clearly GUI. And what is very important is to be able to provide clear, precise, and of course, consistent test report for each step. So the idea is that this AI test case runner acts as a tester, manual tester, executing a test case. If we go to see a little bit more how it works, so you have the test case. We will do it with this test case. It's a typical test case, and this test case can be in GRX-Ray, in whatever tool you have as a test management. So the agent reads the test case step by step, interprets the test intention, and perform, meaning that going to the application and for each step, check the expected result. And if it's okay, it's a success step or passed, then you go to the next one, etc. Sometimes, at the end, there is some report to the test analyst, and sometimes there is a need to open a dialogue with the test analyst. So that's the basic idea. Our architecture is a 3-agent architecture, meaning that we have an orchestrator agent, an actor, and an asserter. It's the orchestrator is in charge of managing the progression in the execution of the test case, reading the test action, the expected results, on providing the action to do to the actor. The actor is the one with all the capabilities, the tools to act on the browser, to be able to open a browser, to navigate and to select a drop-down menu or whatever is needed. After a command, after an action, there is a screenshot that is recorded. The screenshot is also passed to the orchestrator. that gives this screenshot to the assertor to check the expected result and to analyze what is the situation with expecting what is expected. And then the orchestrator analyze and decide the step verdict, if the step is passed or failed, or if there is any error. This is a typical architecture, between an actor. But what is important in software testing is to be very, very, very precise when you execute a test case in this assertion phase, because you need to be sure that you avoid any false positive, meaning that you think it's okay, but it's not, regarding the expected result. Let's have a short demo. So if we will have a short demo. We are currently in the development phase, but we develop a demo version to be able to share where we are exactly in this journey. So up, I will go here. So here is the application. It's a demo application actually that mimic an application for classifieds. Here is a test case. You can see we will perform the first test case here. Here, we can see an already done execution. This test case is done in success. And we'll go back here, but we will launch another one here. So to launch an execution, first we have to provide the target, the application you want to test. You have to provide the steps and the expected result. And the easiest way is to make a copy and paste on your steps, and it's done. You can see all the action on expected result here, and then we can run the test. So not to spend time to write, we will go back, but here is the result of the test execution. And what is important is that you have some evidence of test execution. For example, if we go here, you have to go to the application, and the expected result is the home page is displayed, and you can see that there is some analysis on the basis of the screenshot of if it fulfills the assertion. Well, it's evident you have this is here the keyword, etc. But if we go a little bit later, it's a little bit more challenging. For example, the step 5 of the test is to reorder, the list of classified, because the idea is to change from newly listed to lower price first. You can change the way it's ordered, and you can see the screen, and you can see an evidence. It's really sorted by, that lower price first has been selected, and here you see that it's the right order, and it will compare with the previous one where you can see that it's newly listed with the higher price first. So it's very precise, and you expect that this is really checked. A human will do it, and the AI agent is also doing it on the basis of the screenshot analysis. And then the result here is okay. It's this step is passed. The source screenshot confirms that the sorting option is selected, and the order is okay here. So it's based really on reasoning, because the LLM have to confirm that this one is the first one is a lower price than the second one. Yeah. And then the last action is verify that each listing shows a title thumbnail image, price, location, on date post. And you can see here that it's exactly what is confirmed here by analyzing everything. So what I want to really say is that it's very precise. So let's go back to if we go here, we see that it's progressing on, well, almost finished. So let's go back to the presentation because I see that the time is progressing. So better to go back. So you have as an input your test case. The agent interprets your test case, execute on the application, and check the result. So now let's go to the question of the trust. Trust cannot be decreed. I mean, trust is built on the observation that the agent is operating correctly. So if we go on the user point of view, the user can consider the agent as a subcontractor. And as you know, when you first work with a subcontractor, you are careful, meaning what happens really, on is the job done really, and you need evidence. So is exactly what happens first with the agent, because the user wants to be sure that everything is okay, and he needs very precise test execution report, evidence of execution, to be sure that the quality, and then over the time, of course, you observe the confidence it's here. For the R&D, for our team developing, actually, what is important is the data. We need data to gain our confidence in our own development. So it's testing, actually. And we have developed a large benchmark of representative test cases on multiple web applications. And we have all this test case with very precise indication to be checked automatically. And then, on the basis of this large benchmark that we continue to reinforce, we gain this confidence in the capability and execution. We also see some problems that may happen, and we correct them. So, building confidence, building trust is really based on the experience, on testing, which is, nothing new, is exactly what happened in our quality assurance activity. So just finish on just two slides to sum up. Test execution have been ever an issue, a pain point in software testing. And now, currently, we have mainly two solutions. Either there is this manual testing activity, but you know what it is. It's costly. There is reduced availability of the people on turnaround, etc. Or you can develop some specific automation effort, meaning develop specific testware that can be automated test script, but also low code, no code, everything. But what is important is that you have to develop specific activity. Of course, AI and GenAI will help and is helping, but at the end of the day, when you want specific testware for automation, you need to create it and to maintain it. And we can see that AI agent interpreting functional manual test, it's now a new way. It's an alternative of, and this is not automation because there is no automation activity, no new tools, no test adaptation. It's exactly the repository as it is, that is interpreted by the agent to run the test. So, where we are here in the technology, and it's really exciting based on, the rapid evolution of the agentic technology in generative AI. Okay, if you are interested in a trial, please send an email or please contact me on LinkedIn or here you will contact the R&D that is developing the agent. And now it's time for question.
Thank you, Bruno. That was really a very interesting presentation. I know that I enjoyed it, and I'm sure that everybody that is watching also enjoyed this. So we have a couple of questions, so let's jump into them. I'm sure everybody would love to have some feedback from you. So how do you see the dialogue between the AI agent and the test analyst?
Actually, it's a very important aspect of agentic AI. On what is really new, because now we are working with LLMs, with chatbot, we have some prompt, we have some queries. And in this dialogue is the inverse, meaning the agent need help at a time or need more information. And this is the agent that will take the decision to open the dialogue. And you have seen during the registration to the webinar that at the time the agent needs the name and email address, and then he stop working and to say, okay, I need your email and address just to finish the job. And it's exactly how during the testing execution, the agent will stop and say, okay, I need your help for this test case. But what is important is that we think that we can learn from this dialogue. And like a junior is learning from a senior, the next time I will use this learning not to need this help, because I know what you prefer, what you want, and it's part of the knowledge badge that I am constructing as an agent.
Thank you so much for that feedback, Bruno. All right, let's have a look at our other questions that we have. Do you think that test agents will replace automation as we know it today?
Actually, we don't have the answer yet, but it's I think we have a new capability. On the new capability, we don't know exactly which part of the current automation activity will disappear, but I'm certain that part will disappear. And it's a good news for functional testers, because it means that what is important is the quality of the test case that you give on your agent, and it's in natural language, and it's based on your knowledge of your application, and is exactly what is testing, actually. So I think that will be a new distribution, a new sweet spot for automation and a sweet spot for agentic or AI agent in test execution.
Yeah, definitely. All right, let's have a look at another question. Is test data protected when using such an AI agent?
Yeah, it's of course a very important question. The answer is yes. There is no training with the data. There is exactly what the companies are doing with the LLMs. They have guarantee on the contract. They have procedure to be sure that the company protection data. So it's exactly the same. Actually, it's exactly the same usage on condition on restrictions that we need for agents that we have for chatbot. Actually, yeah.
Yeah. Well, thank you, Bruno. We are then coming to the end of this session. And if you have any additional questions, please pop them in the chat. We can pass it along to Bruno and he can answer them for you and give you a little bit more insight. And then we also want to inform you that all the presentations and this presentation will be available to rewatch on all our social media channels, as well as the testingsummit.com website. And then lastly, please remember to vote for this presentation and for Bruno by visiting the testingsummit.com website, going to his landing page and submitting your votes over there. We will be announcing it very soon. So thank you for everybody that's attended this session, everybody that's attended the Testing Summit this entire day. And Bruno, thank you for you. Thank you for sharing
Thank
your
you,
valuable
Nami.
information. I'm sure that everybody has learned a lot, and this was quite interesting. So have a lovely rest of your day, and we look forward to seeing some of our attendees in our next session that we have. Thank you.
Thank
Bye-bye.
you, all of you. Bye.
Software testers. Move beyond theory and master testing with the AI-powered ISTQB add-on practical tester by A4Q program. The ISTQB add-on practical tester by A4Q equips you with the theoretical skills and practical competence to truly excel. Learn how to apply black box testing like a pro. Estimate accurately, write flawless defect reports, and catch issues early. The ISTQB add-on practical tester by A4Q complements your ISTQB certification by turning knowledge into powerful action. Visit our website and find out more information.